In this video, I'm doing a work problem that involves pumping water out of a tank. So we've learned in class that we can set up an integral for work that involves density, or rho, times acceleration due to gravity, times the integral, which is bounded by the distance that the water is being pumped, A to B, and then distance function. This is the distance that a slab of water would be pumped out times the volume of that slab of water. So let's say we make a little slab of water right down here. And it's going to have a basically rectangular shape. Okay, if you visualize what this tank is going to look like, it's going to be rectangular because this goes back here up so many feet. And so the volume is going to be length times width times height. Well, the length is given to us. It says that it is 5 meters long. So the length is 5. The width we don't know, and that's what we're going to have to figure out. And then the height or the thickness of this little slab is going to be delta x. So how do we figure out the width? Well, this is where we need to use similar triangles. So let's create a triangle over here. That looks similar to the tank. And we know that the tank is 8 meters wide. So that means this distance here will be 4. The tank is 10 meters deep. So that means this is going to be 10 meters. And if we create another little triangle in here, we want to measure the water depth from x equals 0 at the top to x equals 10 at the bottom. So that means this distance measured from the top is an x value. So this distance down here would be 10 minus x. And I'm just going to call this r. I like r. It's not really a radius, but r is going to be 1/2 of the width. The width is going to be this entire distance across here. So I'm going to call that r. So r, to calculate that, we are going to create a proportion. 4 is to 10 as r is to 10 minus x, which becomes r is equal to 4 minus 2/5 x when we do some cross multiplying. That means that the width, which is 2 times the radius, is going to be 2 times 4 minus 2/5 x, or 8 minus 4/5 x. Putting that into our little formula up here for volume, we have 5 now times our width, which is 8 minus 4/5 x. That gives us 40 minus 4x. So I'm going to write the volume down here again. Volume is going to be 40 minus 4x, and of course, times delta x. You can't forget the delta x up here. And now the distance function. What is the distance that water is being pumped out of this tank? Well, I said that x is being measured, x equals 0 from the top to x equals 10 at the bottom. So x is the distance that the water is being pumped out of the tank. But let's not forget that we have a 2-meter spout up here on the top of the tank. So we have to pump it a distance of x plus another 2 meters. so x plus 2. Well, putting all together in our integral, along with the fact that the acceleration due to gravity is 9.8 meters per second squared, and the density of water is 1,000 kilograms per meters cubed. So we're going to have our work function is 9.8 times the density, 1,000. And our bounds of integration, again, is the distance the water is being pumped from x equals 0 to x equals 10, times our distance formula, x plus 2, times our volume formula, 40 minus 4x, and the delta x becomes our dx. And that is the basic integral. Now we can clean it up just a little bit if we'd like, and make that 9,800 times the integral from 0 to 10, and that's going to be 80 plus 32x minus 4x squared dx. All right, so from here it's just a matter of evaluating the integral, and you may do that in Desmos or you may do it by hand.